Okay, 2017. So we have a big circular disk of mass 4m and centre O. It's got a radius of 4a. We then have a hole cut out of it, radius 2a, and the centre of the hole is at a point B, where the distance from A to B is 5a. Now what we need there is to get the mass. So if we'll be looking for the mass of the cutout, because we'll be looking for its moment of inertia, and we'll subtract that moment of inertia from the moment of inertia of the entire shape before the hole is cut. And to get the mass, we'd use the mass per unit area of the entire shape equals the mass per unit area of the cutout. Again, because it's a uniform circle, we can do that. Okay, so part 1. Find the moment of inertia of the lamina about the axis of rotation, which is A. So basically we're just going to get the moment of inertia of the small cutout circle about A, the moment of inertia of the complete larger circle before the cutout, and subtract the two of them. Part 2 then, we're told the lamina is hanging at rest with C vertically above or vertically below A when it's given an angular velocity of that. The lamina turns through an angle of theta before coming to instantaneous rest. Show that the distance of A from the centre of gravity of the lamina is 11a over 3. This is a centre of gravity question. You'd use the sum of the moments equal the moments of the sum, and the distance would work out as 11a over 3. I'll leave that with you. For part B, it's an energy question. So it's given an initial velocity, so initial angular velocity, so it's going to have kinetic energy, and that kinetic energy is going to be equal to the potential energy it has when it swings through an angle and stops at its highest point. Solve for h. Once you have h, you just need to use a bit of trigonometry for the angle of theta. Okay, 2006. A bit of a change now. So I'm just looking at the last part. Find the vertical thrust on the axis when the rod is vertical. So when the rod is pointing straight up, the only two forces acting on it are the force down and the reaction up towards the axis of the rod. So that means if the thing is moving in a circle, it has a centripetal force, and the net centripetal force is the reaction minus the weight of the object, so R minus 3mg, and that's going to be equal to m or w squared, where m is the mass of the object, 3w. We're looking to solve for R there, and you should get that out fairly easily. 2016. Okay, we'll have a look at part 2 first. Calculate the kinetic energy of the wheel. If you read through it, the wheel is rotating, so it'll have rotational kinetic energy. It's also travelling on a horizontal road with a speed, so it has a linear kinetic energy as well. So the total kinetic energy is the sum of the rotational and linear kinetic energy. Part 3. The wheel, which is rotating along a road at a speed of 5 meters per second, comes to an incline, and the angle is inverse sine of 1/5. How far will it travel up the incline before it stops? So we're looking at the diagonal length, or the distance up along the plane. That's what we're looking for here. But if you use the kinetic energy at the bottom equals the potential energy at the top, you can calculate the vertical height reached, and with that vertical height and the angle, you should be able to get the diagonal distance.